A resistor limits the amount of current flowing through a circuit by presenting opposition or resistance to the current flow. Think of yourself on the football field. You represent current, are on the offense, and you want to run for a touchdown. How will you have an easier time down the field? Through 100 defensive men or 220 defensive men? Good luck with either, but you would definitely have a more difficult time getting through the 220 men. Welcome to our first video podcast on electronic components. Our first circuit shows us how a resistor works. In this circuit, the current flows from the negative terminal of the battery all the way to the positive terminal of the battery, passing through both the LED and the resistor. As current passes through the LED, it lights up. The more current flowing past any given point, the more light. The control in this circuit is the resistor. Remember the four necessary parts of a complete circuit: a source, conductors, a load, control. The resistor controls the current flow in the circuit. The smaller the resistance value is, the smaller the opposition to the current flow, and therefore the higher the current. The higher the current is, the brighter the LED. See, for example, how bright the LED is with the current resistor value of 100 ohms. On the other hand, the higher the resistance value is, the greater the opposition to the current flow and the lower the current. The lower the current is, the dimmer the LED. Less juice, less light. Notice what happens as you change the resistor to a 220 ohm or red, brown, gold resistor. Did you notice the light is dimmer? Did someone say inversely proportional? Yes, those long math terms are used out there in the real world too. Remember our scenario about the defensive line. Who will you have an easier time pushing through? Defensive men resist. Resistors resist. The higher the resistance, the lower the current, and the dimmer the light. The lower the resistance, the higher the current, and the brighter the light.